Hi everyone, welcome to mathworld. This video is to discuss Cambridge International AS and A-Level Further Mathematics for paper 2, which is Further Pure Mathematics 2, and this is for May-June 2023, and the code is 9231/23. Alright, so let's get started. Now, first question is find the Maclaurin series for inverse sine x up to and including the term in x cubed. So Maclaurin series means that we need to differentiate third time because of x cubed and let the x be 0. So now I will let fx equals to inverse sine x. Then my f0, it will be inverse sine 0. Then now when you need to calculate this value, please change the mode of calculator to radians. Then you get 0. Okay, then after that f prime x. So this f prime x, you can just use the formula from the formula list. So basically differentiate inverse sine x over a, it will be 1 over square root of a squared minus x squared. So from here your a is 1. Okay, therefore you will be getting 1 over square root of 1 squared over minus x squared. So this is 1 over square root of 1 square minus x squared. Then I will change this to square root 1 over square root of 1 minus x squared. And I know that I need to differentiate 3 times. Therefore, I will move up the square root. This will be 1 minus x squared to the power of negative half. Okay. Hence, your f prime 0 is going to be, so I will substitute here, 1 over square root of 1 minus 0 squared, which is 1. Now, the next differentiation, f double prime x, will be based on the latest form of the differentiation, which is this. Alright, so now we have another formula. When you need to differentiate fx to the power of n, it will be n, then fx to the power of n minus 1 times f prime x. Okay, so from here, I will bring down the negative half, then remain the bracket. The power instead of minus half, now again you have to minus 1. Therefore, it becomes negative 3 over 2. And now when you differentiate the brackets, it will be negative 2x. So now I will simplify. The minus will be the minus half and 2 will be cancelled off. Okay, therefore I will get x over the power, the bracket. So it will be x over 1 minus x squared to the power 3 over 2. This is my simplest form. Right, so my f double 0, it will be 0, because of 0, the numerator is 0, so 0 over any value is 0. So now, my third derivative. Okay, so now I need to differentiate this form. So, before I differentiate this form, I have to apply another formula, which is the quotient rule. So, d over dx, u over v. It will be v squared vu prime minus uv prime. Okay, so before I get this, then I better write down my u and v first. So my u equals to x, u prime will be 1. Then my v is 1 minus x squared to the power of 3 over 2. Then my v prime is going to be 3 over 2 bracket 1 minus x squared to the power of half, because I'm using this power rule. Then after that, when you differentiate 1 minus x squared, it will be negative 2x. And now the half and 2 will be cancelled off. Okay, then I will rewrite. It becomes negative 3x, then power half, means that it's square root. Okay, so now my third derivative, by using this quotient rule, it will be over v squared, right? So it will be 1 minus x squared to the power of 3 over 2, then I squared. Then now, the numerator will be v, so 1 minus x squared to the power of 3 over 2, u prime, which is 1, minus uv prime. U is the x, v prime is this, so negative 3x square root. Alright, so I will leave it in this form because I just need to get the macaron series up to x cubed, which means I just need to differentiate up to third derivative. So after this, I will just let the x be 0. So for the first term in the numerator, okay, here, 1 minus 0 squared is 1, right? So I will just write 1. Then this whole term, the second term on the right hand side, the second term in the numerator will be 0 because of the x here. So I will just write 0. Then over, then 1 minus 0 is 1. Alright, to any degree is still the same. Therefore, this is 1. Alright, so now from here, my macaron series. It will be inverse sine x. Okay, the formula is basically, macaron series formula is fx equals to f0 plus, okay, the macaron series of fx is f0 plus x f prime 0 plus x squared over 2 factorial f double prime 0 and so on. Okay, so here I will just replace the f values that I have found, f0 values that I have found. Okay, so it will be f0. So my f0 is 0. Okay, so here it will be 0. Then plus the first derivative is 1. So 1 times x. Then plus the next one is 0. So it will be 0 here. Okay, 0x squared over 2 factorial. So it will be 0x squared over 2 factorial. Then plus the third one will be 1. So it will be 1 times x cubed over 3 factorial. Then plus dot dot dot. Okay, so from here I will just simplify. I will get the first term I will be getting, first term equals to 0, second term is x, third term is 0, and then last term will be x cubed over 3 factorial. So you can leave your answer in 3 factorial, or you can just simplify into 6. Okay, so that's the macaron series for inverse sine x. Now B, deduce an approximation to this integration, giving your answer as a fraction. So deduce means that you solve by replacing the values. Alright, so we know that differentiate inverse sine x is 1 over square root of 1 minus x squared. So if I integrate right side, right, let's say here I integrate right side with respect to x, my answer will be inverse sine x. So this integration is same as the part B question. Alright, so from here I will just write integrate 1 over square root of 1 minus x squared dx is going to be inverse sine x plus c. So the inverse sine x, I have found it here in the macaron series. So I will replace it by x plus x cubed over 6 then plus c. Okay, so this is the integration in terms of x. But then now we need to solve in terms of u. So integrate 1 over square root of 1 minus u squared du, limits 0 to 1 over 5. So you just change the x to u. Right? Change the x to u. Then ignore the plus c because now with limits. Then I will just write u plus u cubed over 6 with limits 0 to 1 over 5. Okay, then this integration is going to be 1 over 5 plus 1 over 6 here. U cubed over 6, I can take out the 1 over 6. It will be 1 over 6 times 1 over 5 cubed. Then minus everything is 0. And now you need to leave your answer in fraction. So the first one will be 1 over 5. And the second term will be 1 over 750. So when you simplify, this is 151 over 750. So this is the solution for B. Okay, now question number 2. The variables x and y are related by the differential equation. You are given a second order differential equation here. Find the general solution for x in terms of t. So now, first of all, I will let the right hand side be 0. Okay, then I will get the auxiliary equation, which is 6m squared plus 5m plus 1 equals to 0. Then factorize these quadratic equations, you'll be getting 3m plus 1 times 2m plus 1 equals to 0. So when 3m plus 1 equals to 0, right, your m will be negative 1 over 3. And then 2m plus 1 equals to 0. That means your m is going to be negative half. Now I get two different roots, which means my complementary function. Now be careful with this. This is dx dt. Therefore, your solution will be x in terms of t. Okay, so it will be x equals to a e negative 1 over 3t plus b e negative half t. So this is my complementary function. Now, next is to get the particular integral, we need to start with the trial solution. So the trial solution depends on the function on the right hand side. Since this is a quadratic, so now my trial solution, it will be x equals to pt squared plus qt plus r. Okay, it is a quadratic, but it is in general form. So now I need to get two differentiations, dx dt and d squared y over dt squared. Then here it should be 2pt plus q, and then d squared x over dt squared equals to 2p. I will let this be the first equation and let the original differential equation as the second equation. So 6d squared y, dx squared, d squared x over dt squared plus 5dx dt plus x equals to t squared plus 10t plus 13 be the second equation. Okay, so now I will substitute first into second equation. So now I will get 6, my second derivative is 2p, then plus 5 multiplied with the first derivative, 2pt plus q. Okay, then plus x. X is the quadratic equation. So pt squared plus qt plus r, that equals to the right hand side, t squared plus 10t plus 13. Okay, so now I will compare the coefficients. So before that, I will just do expansion first. This is 12p plus, here do expansion, 10pt plus 5q, then plus pt squared plus qt plus r equals to the quadratic function. Okay, so now I will just group them first. So I will group the t squared. So when t squared, this is the only term, p. The coefficient is p. Then after that, I group the t. So the term with the t will have the coefficients of 10p plus q. Okay, lastly will be the remaining terms, which will be the constant. Then now I will write by comparing the coefficients. The coefficients of t squared, t and constant. So when I compare the coefficient of t squared, the left hand side is p, the right hand side is 1, because it's 1 t squared. Okay, here. Therefore, I found the p. Now, when I compare the t, 10p plus q on the left hand side will be 10 on the right hand side. And then now, my p is 1, so I will just replace. Since I have 10 both sides, that means my q is going to be 0. Okay, then now I compare the constant. So now I will get 12p plus 5q plus r equals to 13. Again, now you replace the p and q value. So 12p means 12 times 1. The q will be 0. R equals to 13. That means the r is going to be 1. Okay, so once you get this, then I'm getting the general solution. So I'm getting the particular integral. So now my trial solution becomes particular integral. So substitute your p, q, r into this x. So the p is 1, okay, the q is 0, r is 1. So means that I will get x equals to t squared plus 1. Then followed by general solution, it will be x equals to cf plus pi. Particular function plus complementary function. Particular integral plus complementary function. So it will be this AE negative 1 over 3t plus BE negative half t, then plus t squared plus 1. Okay, so that's the solution for this question. Now B states an approximate solution for large positive values of t. So because we have exponential negative t here, right? So when t tends to infinity, exponential of the negative half t will tend to 0, and same goes to negative e negative 1 over 3t also tends to 0. Okay, so when both of these two terms tends to 0, that means your x will tend to the quadratic. Therefore, x approaches t squared plus 1. Alright, so now for question 3, by considering binomial expansions of these two terms, where z is cos theta plus I sin theta, use De Moivre's theorem to show this, where a and b are integers to be determined. So now, I will start with the z is cos theta plus I sin theta. Okay, and now here I get 1 over z. So 1 over z is basically z power negative 1, which is cos theta plus I sin theta to the power of negative 1. And according to the De Moivre's theorem, this is cos negative theta plus I sin negative theta, which is cos theta minus I sin theta, because sin negative theta is negative sin theta. Okay, so from here I need to get this. So now, right, then from here I need to get z plus 1 over z and z minus. So z plus 1 over z becomes cos theta plus I sin theta. This is my z, plus the 1 over z is z to the power of negative 1, which is cos theta minus I sin theta. Then I will be getting 2 cos theta here. And same goes to z minus 1 over z. It will be cos theta plus I sin theta, then minus cos theta minus I sin theta. So the cos will be cancelled off, and you will get 2I sin theta. Alright, so now I will start with these two binomial expansions to prove the cot power 4. So now z plus 1 over z to the power of 4 binomial expansion. So if you still remember binomial expansion, probably I can just use the Pascal triangle. So if let's say here is a plus b to the power of 0, the coefficient is 1. A plus b to the power of 1, it will be 1, 1. Okay, like this. Then let me check. By considering the binomial expansion, or probably okay, this is a Pascal triangle, so a plus b squared. This is a shortcut, 1, 1, then plus together is 2. Then if this is power 3, here 1, 1, plus together 3, here 3. If this is power 4, here 1, 1, right, plus together 4, this is 6, this is 4. So these are the coefficients for the binomial expansion. Right, so I will get, this will be the the coefficients from the binomial expansion, and also this is a shortcut from the Pascal triangle. Okay, here is 3. So I will use this Pascal triangle to get the binomial expansion, which means my first term is z power 4 because the coefficient is 1, then plus the next coefficient is 4. So 4, but for the binomial expansion, we are reducing the degree of first term and increasing the degree of second term. So it becomes z cubed, then 1 over z. Okay, next coefficient is 6. Z squared, 1 over z squared, then followed by 4, then z degree 1, 1 over z degree 3, plus last term with degree 4, and the coefficient is 1. So now from here I will simplify. Z4 plus 4. Okay, z cubed, when you simplify these two terms, z cubed times 1 over z, it will be z squared. Then the third term will be 6. Fourth term will be 4 brackets 1 over z squared. Okay, then the last term, just bring in the degree 4. Now, first and last term with the same degree, I will group them together. And the second term and the fourth term will be the same, so I will factorize the 4, same degree, so I will factorize the 4, then you get z squared plus 1 over z squared. Lastly, the third term just remain plus 6. Okay, now we need to get what is the z degree 4 plus 1 over z degree 4. So from here, we get this. Z plus 1 over z is 2 cos theta. So z minus 1 over z is this result. Okay, so then from here, I will have two important results. So the two important results basically derive from, or just expand from here. Okay, so it will be z degree n plus 1 over z degree n. Imagine when it is n, which means here is n, then power n. When power n based on the De Mor's theorem, this one becomes cos n theta. Okay, which is the same concept as this, plus I sine n theta, which means here becomes n theta, n theta, n theta, n theta for all. So when you plus together, this is n theta. Okay, same goes to the next one. It will be n theta when here degree n. Okay, so here I will get two important results. Means that I should write this here first. So z degree n plus 1 over z degree n is going to be 2 cos n theta, and the minus, it will be 2i sine n theta. Okay, these two are the important results. Okay, so now I will replace it here. I will apply it here. So now I will use the plus and let the n be 4. Then I will get 2 cos 4 theta. And the next one is 4 brackets 2 cos 2 theta plus 6. Now for the left hand side, the z plus 1 over z I will replace by 2 cos theta. So here 2 cos theta to the power 4. So when I bring in the 4, the power 4, 2 power 4 is 16. It will be 16 cos power 4 theta. Okay, and now when you look at the question over here, we need to get cot power 4. Cot power 4 is actually the cos power 4 theta over sine power 4 theta, which means now I need to get what is my cos power 4 theta. So I move the 16 down, so I will get 1 over 16, then 2 cos 4 theta plus 4 brackets 2 cos 2 theta plus 6. So I can simplify, I can divide the whole equation by 2, okay? Or probably I can just say I cancel off the numerator and denominator with the common factor of 2. So here 2 cancel, this will be 3, then this becomes 8. So now I will get 1 over 8, then cos 4 theta plus 4 cos 2 theta plus 3. That is my cos degree 4 theta. Okay, so done for the first expansion. Now continue with the second expansion, the minus. So the z minus 1 over z degree 4 will be the same coefficients as this. Okay, as this expansion, but be careful with the second term now. Instead of plus z, you change to minus z. Okay, so I will copy from the previous expansion. So these are my 5 terms. Then now I will simplify. So actually the difference is just the when you look at the odd degree of negative 1 over z, it will be negative later on. Otherwise, it will be positive. Okay, so here I will just add on negative. The rest copy from this step, right? The previous step. So here plus 6 then minus 4 brackets 1 over z squared. Then again, use the same concept, group the terms with the same degree. So now when you look at this now, the second term and the fourth term, the common term is minus 4. So I will factorize minus 4, then you will be getting the plus. And the last one is plus 6. And now use the same concept, okay, same formula as this. Just change to the cos 4 theta for the first term, 2 cos 4 theta, then minus 4 bracket, 2 cos 2 theta, then plus 6. And now z minus 1 over z is basically this result, right? Which is 2i sine theta. So I ignore the power n. So it will be 2i sine and theta, 2i sine theta. So here I will get 2i sine theta to the power 4. So bring in the power 4, I will get 16 I degree 4 sine degree 4 theta. Now for your information, I squared is minus 1. I degree 4 is square of I squared. Therefore it's minus 1 squared. I will be getting 1. Then here I will get 16 sine degree 4 theta. And again now 16 move down, and then you can just divide. Or before I move down, I can just divide first. So divide by 2. Then here becomes 8. Okay, then now I move down the 8. So it will be 1 over 8. Then cos 4 theta minus 4 cos 2 theta plus 3. Okay, so now when you look at the question here, your answer will be in terms of cos 4 theta, cos 2 theta, and the constant. So now cot degree 4 theta, it will be cos degree 4 theta over sine degree 4 theta. Then now replace the expressions, right? So substitute the expressions that you have found. So here becomes 1 over 8 cos 4 theta plus 4 cos 2 theta plus 3 over 1 over 8 cos 4 theta minus 4 cos 2 theta plus 3. So obviously the 1 over 8 can be cancelled off. So now I cancel 1 over 8 from numerator and denominator, and at last I will be getting cos 4 theta plus 4 cos 2 theta plus 3 over cos 4 theta minus 4 cos 2 theta plus 3. Okay, so when you compare with the given form, now the A will be the coefficient for cos 2 theta and the B will be the last term. Then the rest are the same, right? So it means that now I will just write my A equals to 4, my B is 3. Okay, so that's the solution for this question. Now for question number 4, curve C has this equation. Show that at the point minus 4, 3 on C, this is the dy dx. So now I will rewrite the question first. Now this is actually the implicit equation. Okay, so when you differentiate implicit equation in terms of fx, right? Let's say for example, you need to differentiate fy with respect to x. So you can use the chain rule, which is d over dy fy, because your f is a function of y. So when you differentiate, you must differentiate with respect to y. Then you times dy over dx. So I'm going to use this to differentiate the first term, 4y cubed. So now, when you differentiate 4y cubed with respect to y, it will be 12y squared, then times dy dx. So that's the meaning of this chain rule. Then plus, for the second term, cube degree 6 of x plus y. This is using the power rule. Okay, power rule is d over dx fx degree n. This is the power rule. Then it will be n fx degree n minus 1. Then differentiate the fx using f prime x. So now I will get 6 x plus y degree 5 Then now I differentiate the x plus y with respect to x. So the first one is x, therefore you get 1, plus the y, when you differentiate with respect to y, it will be 1 dy dx. Okay, right hand side is 0 because it's a constant. So now at -4, 3. So this means the x is -4, the y is 3. I'm going to replace the x and y in the previous step. Okay, so 12 3 squared dy over dx plus 6 x plus y, so -4 plus 3 to the power 5 multiplied with 1 plus dy dx equals to 0. Then from here, the first term I will get 108 dy dx. Then now -4 plus 3 is -1. -1 degree 5 is negative. Therefore, I get -6 bracket 1 plus dy dx equals to 0. Now I will do expansion because we need to show dy dx is 1 over 17. Alright, so 108 dy dx minus 6, bring in the term, minus 6 dy dx equals to 0. So first term minus third term, it will be 102 dy dx, and at the same time, the minus 6 will be moved to the right side. So it becomes positive 6. So now my dy dx is 6 divided by 102. And this is same as 1 over 17. Okay. So done for the A. Now for B, find the value of the second derivative. Right, at the point -4, 3. So now I have to copy my this. Okay, 12y squared dy dx, because I didn't get the expression for dy dx just now. So 12y squared dy over dx, then plus 6 times degree 5 of 1 plus y, then times 1 plus dy dx equals to 0. So I get this in the previous part, and now I need to get second derivative, means that I need to differentiate one more time for this equation. So now again, when you look at here, it actually consists of two terms. Therefore, I need to differentiate using products rule. So d over dx uv, which is uv prime plus vu prime. Here I will direct differentiate. And at the same time, you need to differentiate the y, use a chain rule that I have mentioned just now. So firstly, uv prime means that I need to rewrite the first term, differentiate, okay, v prime, differentiate the dy dx with respect to x. That is the d squared y over dx squared. Then you plus, keep the dy over dx, and differentiate 12y squared. So this is in terms of y. When you differentiate with respect to x, again you use the chain rule. So differentiate 12y squared with respect to y first. That is 24y. Then you times with dy over dx. Now, done for the first differentiation. Now for second differentiation, what to do is, again, this is the products rule. Keep, this is the u, this is a v. Okay, so now maybe I can just write down the working here. So let's u equals to 6 bracket x plus y degree 5. So now when I need to differentiate, my u prime is going to be bring down the 5. So I will get 30, then x plus y, then degree 4, then differentiate 1 plus y, it will be 1 plus dy dx. This is my u prime. Okay, then for the v equals to 1 plus dy dx, my v prime is going to be 0 for the first term, and second term will be d squared y over dx squared. And now I will substitute into this formula. So it will be u, so 6x plus y degree 5, v prime, d squared y. Then plus vu prime. So this is my v. Okay, because my u prime is has a lot of terms, so I will just write next line. So it will be 1 plus dy over dx, then u prime 30, multiply with 30, then x plus y degree 4, multiply with 1 plus dy over dx. Okay, right hand side equals to 0. So when I differentiate, I still get 0. Now, this is my second derivative. I have two lines here. So now, just replace x by minus 4, y by 3, and at the same time, I have the dy dx here. So the dy dx we have found in the previous part, which is 1 over 17. Which means your dy dx equals to 1 over 17. So replace all these values. I will get 12 bracket 3 squared d squared y over dx squared for the first term, then plus 1 over 17, 24 times 3, okay, 24 times 3, then dy dx. So again dy dx, so I can just square this, right? Then plus 6. So this x plus y degree 5, or x plus y itself, you can just check here. This is x plus y. See here, x plus y, I'm getting minus 1. Okay, so I will just replace it by minus 1 then. So this is going to be minus 1 degree 5. After that, d squared y. Alright, then the next term is 1 plus dy dx. Then multiply with 30. Okay, remember just now x plus y. Here, x plus y. Here again x plus y. It will be minus 1. So I will replace it by minus 1. Then 1 plus 1 over 17, close bracket, and equals to 0. Okay, so now when you calculate, the first one is 102 d squared y over dx squared. Wait, let me check. It will be 12 times 9. Okay, 12 times 9. 108. So here is going to be 108 d squared y over dx squared. Then the next one is 72 over 289. Then here is going to be minus 6 d squared y over dx squared. And this whole term is going to be 9720 over 289. Okay, so then you will get left hand then equals to 0. Now, the first and third term plus together is 102 d squared y over dx squared. Alright, and then for these two terms, for the remaining two terms, when you plus together and move to the right side, it will be negative 576 over 17. Okay, therefore, your dy dx, your d squared y over dx squared is going to be just the right side value divided by 102. So, negative this value times 1 over 102. Therefore, that is negative 96 over 289. Alright, so that's the solution of this question. Okay, so let's move on to next question, number 5. So number 5 is starting from definitions of cos and sine in terms of exponentials. Prove this formula. Okay, so now I will start with the cos x. It is half of ex plus e minus x. And then the sine x is half of ex minus e negative sine x. Now, left hand side equals to 2 cos square x, which is 2. Now, the cos is this. So, this is same as 2 cos x degree 2. Alright, so I will get 2 times half of exponential x plus e negative x, then squared. So now I bring in the squared. It will be 2 times 1 over 4, then ex plus e negative x squared. So now I need to do the expansion, but 2 and 1 over 4 will be 1 over 2. So for the expansion, we use a plus b squared. It will be a squared plus 2ab plus b squared. This is the formula. Now I will get e2x plus 2 times ex times e minus x. So now ex times e minus x, we have a formula which is ea times eb. So it will be ea plus b. Right? So this is ex minus x, which is e0. E0 is 1. So I will just get 2 then. Then plus e negative 2x. So then from here I can change these three terms into okay, I need cos 2x plus 1. So look at here. If cos 2x plus 1 means that I should get this. Okay, but here 2x, here 2x. So it means that I need to keep these two. Alright. Then I need to rearrange it first. So e2x plus e negative 2x. Then I group them. After that, plus another 2 outside. So when I times in this minus, this half, okay, I times in the half. So it will be half of e2x plus e negative 2x. Then the half times 2, it will be plus 1. So for the first term, it will be the cos 2x. And last term will be plus 1, which is same as the right hand side. Okay, so proven. Right. So now B, find the solution of this differential equation, dy dx plus 2y inverse tangent, hyperbolic tangent x equals to 1, for which y equals to 1 when x equals to 0. Give your answer in y equals to fx form. So now dy dx plus, now I rearrange, okay, y brackets 2 hyperbolic tangent x equals to 1. Here I rearrange into this form because I'm going to use the integrating factor. You cannot apply the separable variables here because when you move this term to the right side, you still have the y and x. You cannot split the y and x completely. Okay, so once you have obtained this form, your integrating factor I is exponential of the bracket. So 2 in hyperbolic tangent x dx. To integrate this, it will be exponential integrate. So the 2 can be taken out. Hyperbolic tangent x is hyperbolic sine x over hyperbolic cos x. Then now, for your information to integrate this sine x over cos x, we need to use ln formula. So ln formula is integrate over fx. Numerator is f prime x. This is ln fx, which means, right, the numerator is the differentiation of denominator. So now, differentiate cos is positive sign, which means this is basically e2 ln cos x. Okay, and now, because of e and ln, we can simplify, but there is a 2 there. So it means that we need to apply another formula, which is a ln b is ln b to the power of a. After that, e ln fx is going to be fx. Right, so I will apply the first one, the first green formula, which is e ln cos x to the power of 2. Then e and ln cancel off, you get cos square x. Square of cos x is same as cos square x. So this is my second equation. which is the I. Once you obtain the I, then you times second into first. Now, if you are confirmed that your integrating factor is correct, then the left-hand side, these two terms, right, will be d over dx yi. Then the right-hand side is just times. So 1 times cos square x will be cos square x. Now, differentiate why cos square x is cos square x means that my y, right, so my y cos square x will be integration of cos square x here. So when we need to integrate cos square x, right, so we need to refer to the double angle formula, which is cos 2a. This formula is 2 cos square a minus 1. And now this is the subject, means I get this subject by moving the minus 1 to the left hand side and change and move the 2 to the right hand side as well. So that means I'm getting cos square x is half of 1 plus cos 2a. Okay, now when you compare, the a is x, right? So the a is x right now. So here I will write my y cos square x will be half of integration 1 plus cos 2x dx. Okay, so now when I integrate 1 with respect to x, I will get x. Integrate cos 2x with respect to x, it will be sine 2x over 2, then plus c. Okay, so now to get the c, replace the x and y by the given values. X is 0, y is 1. So when x equals to 0, y is 1, I will get 1 cos squared 0 equals to half, the x is 0, then sine 0 over 2 plus c. So sine 0 is 0. Okay, but cos 0 is 1. This is 1. That means I will get 1 equals to c. So now substitute into the general solution. You will get y cos square x equals to half bracket x plus sine 2x over 2 plus 1. And now when you look at the answer, you must leave your answer in y equals to fx, means that we need to move down the cos square x. So now 1 over 2 cos square x, x plus, okay, I shouldn't write like that. I will have to write half is just multiplied to the first one, so it will be 1 over cos square x times half, then sine 2x over 2, then plus 1. Okay, then this 1 over cos square x is basically hyperbolic secant square x, so it will be sec 2x. Alright, so because my c I put it outside, so if you want to bring it in, it becomes plus 2 already. So probably here, make it better form, I will just write plus 2 and bring it into the 1 over 2. Okay, bring it into the 1 over 2. Then here I will just take out the half. I will just combine these two together. So I will get half squared of hyperbolic secant x multiplied with x plus sine 2x over 2, then plus 2. Okay, so that's the solution of this question. Alright, so let's move on to the next question. Next question is number 6. You are given this diagram. Then now the diagram shows the curve with equation y equals to this for x between 0 and 1, right, together with the set of n rectangles with width 1 over n. That's why here 1 over n. By considering the sum of areas of these rectangles, show integration is less than un, where un is this fraction. Okay, so here I will get, now look at here, sum of the rectangles, area of rectangles. So remember, this curve is y equals to 1 minus x squared, right? So now, to get the sum of the areas of the rectangles, okay, so the first rectangle, when you look at the first rectangle, I am using the first ordinate for the height. That means this is 1. Okay, 1 minus 0 is 1, 1 squared. Then for my rectangle, my second rectangle, the height is using the first ordinate. That means this is 1 over n. Okay, I mean, this is 1 minus 1 over n to the power of 2. Alright? So same goes to the last one. So the height for this is going to be 1 minus n minus 1 over n squared. Okay, so and then for all the rectangles, the width is the same, unique, which is 1 over n. So now I will write my sum of areas of rectangles equals to 1 over n, the base, right? Then the first one is going to be 1. Okay, so instead of 1, I can just write here as 1 minus 0, 1 minus 0, 0 over n, just write 0, then squared. Okay, then here is going to be 1 minus 0 squared plus the second one, the second height is 1 minus 1 over n squared. Plus until the last one is this height, 1 minus n minus 1 over n squared. Okay, so when you look at here, this is basically 1 over n summation 1 minus r over n squared, because this is our r, right? This is our r. So when you look at here, this is basically r over 0 over n, right? Therefore, your r will start from 0 until n minus 1. This is our last r, so n minus 1. Okay, then from here, I will do expansion. This is 1 over n summation square of 1 minus r over n. You can just expand using quadratic. This is a squared minus 2ab plus b squared. That is the quadratic expansion. Then I will get 1 minus 2r over n plus r squared over n squared. And then the r starts from 0 until n minus 1. Okay, so now you need to prove this later on. Now, for your information, when you refer to the formula list, you will always given the summation r start from 1 until n. Okay, so here our r start from 0. So I want to change to starting r is 1 and then the last r is n. That means I will write 1 minus 2r over n plus r squared over n. Okay, then I plus, now look at here, 0 to n minus 1. That means you are adding 0 to n minus 1. Okay, so now I need to use, instead of 0 to n minus 1, I need to start from here until n minus, until 1. Alright, which means the first tick is extra, so I have to minus this and I plus this term. Okay, right? So this will be the sum from R to 1 until N. Alright, so I minus the first term. So the first term is basically 1 minus 0 squared. Then I minus the first term and I plus the last term. Okay, wait, sorry. Okay, wait. This is R from 0 to N minus 1. Okay, R from 0 to N minus 1 means the green color. So green color is the orange color, right? Wait, I explained wrongly just now. Okay, green color equals to the orange color, right? Plus the first value, plus 1 is 0. And then I minus this, right? Minus the last value, because our green color is just the first value, which is 0, until the last value is N minus 1 over N. Okay, so I should plus the 0 when it is 0 and minus when it is 1. So here should be plus. And then this is minus the last term. Right? So from here, I will get 1 over N summation R from 1 to N. Here, I will just times in. Okay, remember the variable is a R. So this is 1 minus. So the second term, 2 over N is constant. So I will factorize 2 over N. Then summation R from 1 to N. Then plus 1 over N squared summation R squared. Sorry, 1 over N. Okay, I factorize the 1 over N here. So R from 1 to N. Then I will get this is actually plus 1. Then this one is basically 0. Okay, and now I will use the formula list. So remember, this 1 over N times to the whole sum, right? So it means that I should put another bracket. So now you get the sum for the 1 for N terms, because R from 1 to N, that means this is N. Then minus 2 over N. Use the formula summation R. Refer to the formula list. Summation R is basically half N bracket N plus 1. Okay, plus 1 over N. Summation R squared is basically 1 over 6 N plus 1 to N plus 1. Okay, then now, okay, I have there's 1 over N here, right? So it should be another bracket. I missed out one bracket here. This is the bracket. Okay, because 1 over N times the whole sum. Remember here, multiply by the whole sum. So it means that for the next term, I should put another bracket. I should close it here, not close at the summation. This is squared. So now the last term here is plus 1. Okay. So then, now I need to simplify my terms. I get this. So what to do is simplify the terms first. The 2.5 cancel. Then the 1 over N and N cancel. Here also can cancel. Right? Okay, let me check. Alright, I found a small mistake. You see here, this is N squared when you do expansion, but when I come to here, I only wrote N. It should be N squared. Over here, the square is missing. Which means here I still have one more N. Alright, so from here I will do expansion. So this is 1 over N. The N here left minus of N plus 1. So bring in the minus. Then this is 1 over n and 1 over 6. So I will write plus 1 over 6n. Then here I do expansion. Alright. So you will get 2n squared plus 1n plus here 2n. Then plus 1. 1 times 1 is 1. Then plus another 1 outside. Okay, so now I simplify. First two terms will be 0. Then the minus 1 and the plus 1 cancel off. So then I will get the 6n and the n here will be 6n. Okay, because look at here. This is a 6n squared. So the n and n will be n squared. So I will get over 6n squared. And then here, n plus 2n will be 3n. So this is my 3n. Alright, means that I already found the un. So which is 2n squared plus 3n plus 1. Alright, so then from here, I will just write this is the sum of the areas of triangles. So sum of areas of triangles is basically the un. So then final answer, you can just write integration, which is the area under the curve. This integration is less than 2n squared plus 3n plus 1 over 6. Okay, where un, or probably I can just write is less than un, because we want to show that. So less than un, where un equals to the area, sum of the areas of triangle of rectangles. Okay, so this is how we prove it. Now, B, use a similar method to find in terms of n a lower bound Ln for the integration of the graph. Okay, so if lower bound Ln, which means now, okay, so lower bound, we no longer refer to all these rectangles, but we will be referring to the new rectangles, which means it's here. Okay, I will use back the same diagram, that it will be easier. So it will be, instead of using the first ordinate just now we are using the second ordinate of the first triangle, which means this is our first triangle. First rectangle. Okay, I'm using second ordinate. Then for the next rectangle, it will be the 2 over n. I'm using 2 over n. Alright, so the second ordinate, which means for the last two terms here, my rectangle, the last rectangle is at 1. Okay, which is no rectangle. Then my previous rectangle will be based on this value. So the height here becomes n 1 minus, this one will be this height. Okay, so for the first rectangle, the height is going to be 1 minus, because your curve is y equals to 1 minus x squared. So now becomes 1 minus, my x is 1 over n. Okay, then for the second rectangle, the height is going to be 1 minus 2 over n squared. So now we refer to the second ordinate. Okay, so I'm getting this now. So I will write down my sum of the areas, of rectangles okay, for lower bound, for Ln, or probably not for, probably I will just write comma Ln equals to 1 over n is the width, is still the same. Remember just now I said I'm using 1 minus 1 over n squared as a first height. Then 1 minus 2 over n squared as a second height, plus until 1 minus n minus 1 over n squared. Because the last term is actually 0. Okay, the height is 0 here. So no need to consider this. I will just consider up to the previous rectangle. Therefore, this is going to be 1 over n. Okay, now when you look at the terms here, it is in the common term 1 minus r over n, because the r will be starting from 1 until n minus 1. Okay, look at here. They will be in the same pattern. So I will write summation 1 minus r over n, then squared r from 1 until n minus 1. Okay, so from here, I will change it to summation from r to n minus 1. Okay, your summation from r to r from 1 to n minus 1, I will just write here summation r from 1 to n minus 1. The function here, I have to change to summation from r to 1 until n. Okay, so that means you are finding all this sum up to here. Then I need to get r from 1 until n. So it means that I need to add one more. Okay, r from 1 until n. N is here. Right? So that means it is same as summation r from 1 to n, 1 minus r over n squared. So when you consider until n means that you have to add one more, as I mentioned just now. See, I have to add one more here. Alright? So r from 1 to n minus 1, which is here, just to double confirm. Right? So it will be 1 until n, then you plus this. Actually, it's the same, because when you plus this, it's still the same, right? Okay, you plus, because I want to change to n, so it's here. This equals to here, it should be minus, alright? Minus this part. Because if I consider r from 1 to n, you have counted up to here. The purple color. The purple color. Sorry, this is not purple color. Purple color is here. Okay, this is r from 1 to n. Alright. The red color is, the orange color is r from 1 to n minus 1. So that means the red color is the purple color minus this part. Okay, it should be minus. So the minus last part is 0, alright? So here I should write minus 1 minus n over n squared. The height is 0. Okay, so from here it will be 1 over n, then summation r from 1 to n, 1 minus r over n squared. This is going to be 0. Right? So it is the same as just 1 to n. Then now I will do expansion as just now. It will be 1 over n. Then after that, summation 1 minus 2r over n plus r squared over n squared. Then now you just simplify as just now. Okay, this part, this three sum, it is the same as the previous sum. That's why I purposely make it to n. See? Exactly the same. So with exactly the same, alright, remember just now, for these three terms, it will be up to here. Okay, so except the plus 1 means that I will copy all this up to here. Or I will say I copy up to here. Okay, it will be the same. Alright, so I will write n minus 1. I will just direct copy this, the red color, except the plus 1 at the back. So then I will write n minus 1 minus n minus 1, n minus n minus 1, then plus 1 over 6n. After that, 2n squared plus n plus 2n. Sorry, what is that? 2n squared plus n plus 2n plus 1. Okay, I'll copy all these terms from the previous step because it's the same expansion, same summation. So this is from part A. Alright, so now you can simplify. Then you will get I factorize the 6n. Okay, I factorize the 6n. So this 6n multiplied with this n, it will be 6n squared. So I will write 1 over 6n squared. So don't forget there is a minus 1 in the first term here. So when you factorize 6n from minus 1, it will be minus 6n. Then the rest just copy here. Then I will get plus 2n squared plus this is going to be 3n, then plus 1. Okay, then I will get 1 over 6n squared, 2n squared. Now, the first and third term, you will get minus 3n, then plus 1. Okay, so this is our lower bound. So from here, I know that when you refer to the graph, and by referring to the green rectangle, okay, obviously the total area of the rectangle here, alright, or this rectangle, it will be less than the actual area under the curve because this will be the extra part. Okay, so obviously now your integration is greater than the ln. So now integration, which is the area under the curve, is greater than ln, whereby the ln equals to 2n squared minus 3n plus 1 over 6n squared. Okay, so that's the solution of this question. Alright, so let's move on to the next part. So this is 3. Now show that limit of un minus ln when the n tends to infinity is 0. So now limit n tends to infinity, un minus ln is limit n tends to infinity, un 2n squared plus 3n plus 1 over 6n squared. So 2n squared plus 3n plus 1 over 6n squared, you minus 2n squared minus 3n plus 1 over 6n squared. So when you simplify this, the numerators are the same except the middle term. The plus 3n change to minus 3n. So when you minus all together, it will be limit n tends to infinity. First and third term in each of these will be cancelled off. Then I will get 6n over 6n squared because minus minus is a plus. Then at last I'm getting limit n tends to infinity of 1 over n. So then it will be 0. Okay, that's the limit. Now question number 7. The integral in, where n is an integer, is defined by in equals to this integration. So now find the exact value of I to the power of negative 1. Giving your answer in ln a, where a is an integer to be determined. So now I power I negative 1, it will be integrates from 0 to 4 over 3, 1 plus x squared to the power of negative half dx. So the power negative half, it is same as 0 to 4 over 3, 1 over square root of 1 plus x squared dx. Okay, so from the formula list, integrate this is basically inverse sine x. Then limits from 0 to 4 over 3. And now again, you need to leave your answer in ln A. So sine x is ln of x plus square root x squared plus 1. Okay, so now you replace the x by A. I mean, you just replace it by this. That means it will be, before I replace by the ln, I replace the x by 4 over 3 first. It will be inverse sine 4 over 3 minus inverse sine 0. So inverse sine 0 is basically 0. Okay, so now I will just replace the value. It will be ln of 4 over 3 plus square root of 4 over 3 squared plus 1. Okay, and now you simplify, it will be ln of 4 over 3, so the square root becomes 5 over 3, which is ln 9 over 3. 9 over 3 is going to be 3. So that is your first solution. I mean the solution for A, for first part. Okay, now B, by considering the differentiation or otherwise show this formula. So now I start with the differentiation. So we'll differentiate this, we need to apply the products rule. Okay, so products rule, let this be the U, this is the V. So I keep the U, differentiate the V, bring down half n, then remain the 1 plus x squared. The degree you have to minus 1, so half n minus 1. And now differentiate 1 plus x squared, it will be 2x. Now plus, keep the V, so 1 plus x squared to the power of half n, differentiate x is 1. Okay, so now we know that differentiate left side is right side. So now we need to prove this. Alright, whenever you see the I means that integration. So now I need to substitute the limits and integrate right hand side. So I will be getting x with the limits. Okay, so when you refer back to the I, the limits will be 0 to 4 over 3. Then here I will get integration. So before that, I will simplify. The half and 2 cancel. Then I have the n. I will take out the n. So it will be n integrate 0 to 4 over 3. Then I have the x squared because x in front and at the back. Then dx plus another integration. Okay, then now I have to calculate the value on the left hand side. So 4 over 3 times 1 plus 4 over 3 squared to the power of 1 over n minus 0 equals to, this is n. Now because we need to get the I n minus 2 and I n here, so instead of the x squared, I have to change to x squared plus 1 minus 1, because otherwise my x squared will be extra. Then 1 plus x squared to the power of half n. Okay, this half n minus 1 I need to change to half of n minus 2 dx. Okay, then put another bracket for this. Then plus, this is basically my in. Okay, when you refer back, this is my in, exactly the same. So I will plus in. Then now for the left hand side, I will get 4 over 3 times 25 over 9 to the power of 1 over 2n equals to n. This part I will do expansion. I treat this as one term and I expand with this. Then another term, expand with this. Alright, so from here you will get integrate 0 to 4 over 3. Then 1 plus x squared. Here is degree 1. Okay, so when you plus 1 to the degree here, to this degree, is actually just half n. Okay, so I will get half n dx. Then this minus, okay, I will have another n outside. Don't forget this n. Let's say I just times. It will be minus n integrate 0 to 4 over 3. So 1 plus x squared half to the power of n minus 2, power of half bracket n minus 2 dx plus the in. Okay, so here I will get the left hand side. It will be degree half of 25 over 9 is basically 5 over 3. So I will write 4 over 3 times 5 over 3 to the power of n, because I bring in the degree half. Then this is n minus in. Look at here. If here is n, this is n. Now I get power n minus 2. Okay, so now I get this is half of n minus 2. That means my n has been changed to n minus 2, which means this n will be changed to n minus 2 as well. So I'm getting in minus 2. So therefore, I will get in minus 2 because of the power n minus 2 here. Then plus in. Okay, and now we need to get this in as the subject. So it means that now these two terms will be moved to remain on right side. This term will be moved to the left hand side. Okay, then I'm getting the answer soon. So in, first and third term, factorize the in, then you get n plus 1. Then here 4 over 3 times 5 over 3 to the power of n. The minus in minus 2 will be plus. Okay, and now I just need to rewrite in this order. So my n, sorry. So I will write here in n plus 1 equals to, or n plus 1 in. Okay, just write in the given order. Equals to n minus 2 plus 4 over 3 times 5 over 3 to the power of n. So this is the solution. Alright. Now next, a curve has equation y equals to x squared. The x defined from 0 to 2 over 3. The arc length is divided by s. Use substitution u equals to 2x to show s equals to half I1 and find the exact value of s. So y equals to x squared, dy dx is 2x. Now my s is integrate 0 to 2 over 3 square root of 1 plus dy over dx squared dx. So then here will be 0 to 2 over 3 square root of 1 plus 2x squared dx. And now given u is 2x. So u equals to 2x. Therefore, du over dx is 2. And now I need to get dx. So my dx move up, the 2 move down. So half du. And when my x equals to 0, my u is 0. X equals to 2 over 3. My u is 2 times 2 over 3, which is 4 over 3. So make sure you change all to u. Alright, so here will be 0 to 4 over 3 square root of 1 plus u squared. Then the dx is half du. So now I have half integrate 0 to 4 over 3. Then 1 plus u squared degree of half times 1 du. Okay, so that's why now you need to prove it is I1. So this is our I1, this whole integration. Therefore, half I1. Okay, because just now if you remember, in is 0 to 4 over 3, 1 plus x squared to the power of half n dx. So now our n is 1 now. Okay, so done for the first part. And then find the exact value of s, exact value. So now means we need to count what is your I1. So for I1, okay, This is the formula. But then now, let's look at the previous formula. We have this. Okay, then it will be easier to calculate. So I will copy back from, because we have no idea how to, because if you want to integrate this, the working will be very long. Okay, that's why we use back the identity that we have proven. Okay, and at the same time, if you still remember, just now we have counted. You see, I negative 1 is ln 3. So now, to get I1, so I will replace the n by 1. I will get 2I1 equals to 1I negative 1 plus 4 over 3 times 5 over 3 to the power of 1. Okay, so my I1 is going to be half of everything. So I1 is ln 3. So ln 3 plus, this is basically 20 over 9. Then now, I will get I1 found. Then my S is this. So my S is half I1. So it will be half of half ln 3 plus 20 over 9. That means it's 1 over 4 times ln 3 plus 20 over 9. You can just times in. It will be 1 over 4 ln 3 plus. So the 20 and 4 will be cancelled off, becomes 5 over 9. So this is your S. Alright. Now for question number 8. The matrix A is given by this. This is a 3 by 3 matrix where A is not 0, A is not 1. Show that the equation A of x, y, z is 1, 2, 3 has a unique solution, and interpret this situation geometrically. So for unique solution, just for information, unique solutions means that the determinant of A is not 0. Okay, so now I need to prove that it is not 0 here. So determinant of A minus 6A, 2A plus 2. I need to count the determinant first. So here 0, 1 minus A, 0, 0, 2 minus A, minus 1. So to count this determinant, I will fix the first column because it has 2 zeros. So when I fix the first column, the sign is plus for the A. I just need to count the A, that's it. Because the other cross out will be negative. So when I consider the first row, okay, I fix the first column, now I consider the first row, it will be the cross out of A, that's why plus A, it will be remaining of these 4 elements. So I just need to count this determinant. So now for the 2 by 2 determinant, it will be the green arrow minus the purple arrow. Okay, so I will get plus A, negative times 1 minus A minus 0. So from here, I'll get A, negative A, bracket 1 minus A. Or probably I can just write A, bracket A minus 1. Now, when you look at here, the A is not 0, A is not 1. So when A is not 0, A is not 1, that means this is not 0. Okay? When A is not 0, A is not 1. So, therefore, the matrix A, or therefore the equation, has unique solution. Now, how to interpret this? So the interpretation will be three planes intersect at one point. Okay, that's the meaning of unique solution. Only one solution for this. Now, B, find the eigenvalues of A. Show that the eigenvalues of A are A, 1 minus A, and minus 1. So now we need to start with determinant of A minus lambda I equals to 0. So now A minus lambda I means that for the matrix lambda, okay, all this matrix lambda, not matrix lambda, for the matrix A, the diagonal elements will have to minus lambda, okay, because the I is the identity matrix. So I remain the rest, and the diagonal elements, these three values have to be minus lambda. So now I will rewrite. It will be A minus lambda, then minus 6A, 1 minus A minus lambda, 2 minus A. So 2A plus 2, 0, minus 1 minus lambda equals to 0. Okay, and now I need to show lambda equals to these three values. So again, I have 2 zeros in the first column, so I fix the first column. Okay, and when I consider the first row, the cross out is A minus lambda. So I will label the elements in the first column, start with plus, then followed by minus and plus. But since the second and third element in the first column will be 0, so I will just consider first column here. So I will get plus A minus lambda, then determinant 1 minus A minus lambda, 2 minus A, 0 minus 1 minus lambda equals to 0. Okay, so now this is 2 by 2 matrix, 2 by 2 determinant. Just cross multiply, right? This minus another one, minus the red color. Then I will get the lambda values. Means that A minus lambda, then 1 minus A minus lambda, multiplied with minus 1 minus lambda, then minus 0. The red color is 0 when you multiply. So now it is A minus lambda, 1 minus A minus lambda, then minus 1 minus lambda equals to 0. My eigenvalues are referring to the lambda. So the product of these three values equals to lambda means that either the first one equals to 0, which is A, or the second one equals to 0 means that lambda is going to be 1 minus A, or the last one will be minus 1. Okay, so these are the eigenvalues. Okay, so we have proven these three values. Now see, find a matrix P and diagonal matrix D such that A to the power 4 is PDP inverse. Means that now I have to find three eigenvectors. So I will start with lambda 1 equals to A. Alright, so now I will substitute this A into my A minus lambda I matrix. Means I will sub into this and change the determinant to matrix. So the diagonal I have to minus lambda, means that it will be A minus A, then 0, 0. After that, minus 6A, 1 minus A minus lambda, 2 minus A. So minus 6A, 1 minus A minus lambda. Then after that, 2 minus A. Then the last column, 2A plus 2, 0, minus 1 minus lambda. So 2A plus 2, 0, minus 1 minus lambda. Okay, multiply with the matrix XYZ, or I would say that it's vector, and equals to all zeros. It's a 0 vector. Okay, so from here, I need to form three equations to solve it. So A minus A is basically 0. Then minus 6A, 1 minus 2A, 2 minus A. You are getting this matrix. And now I have to form three equations. So the first equation from the first row, so it will be minus 6ay plus 2a plus 2z equals to 0. Let this be first equation. Second equation, I will get 1 minus 2a times y. Then the coefficient for z is 0. So from here, I know that my y is basically 0. Okay, so when I substitute second into first, I will get my y is 0. So 2a plus 2, which is my second term, times z will be 0 because the y is 0 here, which means now my z is 0. Okay, so now we know that we are getting the infinite solution. Since I know the y and z equals to 0, then I will just let the x be t. No need to solve for the last one, because the last one you'll get y 2 minus a times y, then plus y minus 1 minus a times z equals to 0. Again, both equals to 0. Okay, so I let my x be t because your coefficients for x equals to 0 in these 3 rows. So once I get my x equals to t, then my solution, so I will just write here, x, y, z equals to t 0, 0, which means this is t 1, 0, 0. Then I will get my first eigenvector. So E1 is 1, 0, 0 when lambda 1 is a. Okay, so now I have to redo it for lambda 2 and lambda 3. So not enough space. Okay, so when lambda 2 equals to 1 minus a, right? Then I will just replace this by 1 minus a. So I will get a minus 1 minus a, 0, 0. Then minus 6a, 1 minus a, then minus lambda. So minus 1 minus a. Then after that, 2 minus a. Then followed by 2a plus 2, 0, minus 1 minus lambda. Multiply with x, y, z, that equals to all zeros. Alright, so I will get 2a minus 1, then 0, 0. Then minus 6a, this is 0. Then here is 2 minus a, 2a plus 2, 0, minus 2 plus a. Multiply with x, y, z equals to all zeros. Alright, so from here, the second row will be 0, means that I will only get 2 equations. So 2a minus 1 times x minus 6ay plus 2a plus 2 times z equals to 0. This is my first equation. My second equation comes from the third row. So 2 minus a times y plus negative 2 plus az equals to 0. Which means now my y, okay, I can get my y as, okay, here you have 2 minus a. This one, when I move to the right side, it will be 2 minus a. So here, it will be, let me show you step by step. This is going to be 2 minus ay equals to 2 minus az. Okay, then my y is going to be z. Then now I continue this side. So now I will let my z be s. Then this is my second equation. Then from second equation, my y is s as well. Okay, then from here I can find my x. So substitute into the first. So from first, 2a minus 1 times x is going to be, or minus 6ay. So 6as plus 2a plus 2s equals to 0. Okay, so 2a minus 1 times x equals to, here is going to be minus 6as plus 2as is minus 4as. Move to the other side, 4as. Okay, and this is 2s. So when you move to the other side, it's minus 2s. So now my x is going to be, now for the right hand side, 4as minus 2s, the 2s is in common. So I will get 2a minus 1 over 2a minus 1 from the x. Therefore, my x is actually 2s. Okay, so once I get this, I need to rewrite. So, alright, so because of not enough space, I continue over here. Then x, y, z is going to be 2s. My y is s. My z is s. Therefore, this is going to be factorize as. I'll get 211. So this is my E2, which is 211, when the lambda 2 equals to 1 minus a. Okay, so now I will continue this on. I will continue it here because I still have the E3 not yet found. Alright, so now this is the part C of last question. This is question 8. Right, so when lambda 3 equals to the last value is going to be minus 1. So now my matrix will be a minus lambda, then 0, 0. After that, minus 6a. Right, 1 minus a minus lambda. Then 2 minus a. Lastly, 2a plus 2, 0, minus 1 minus lambda. Then x, y, z equals to all 0. So from here, I will get a plus 1, 0, 0, minus 6a, then 2 minus a, then 2 minus a. After that, 2a plus 2, 0, 0. Okay, so you will notice that the second and third row are the same. So it means that we just choose one of the rows and form the equation. So I get a plus 1, or probably I just start with the second row first. So it will be 2 minus a, y equals to 0, which means the y equals to 0. This one is better. Then now I substitute into the first equation, the first row. So a plus 1 times x minus 6ay plus 2a plus 2z equals to 0. Now you replace the y by 0 here. That means a plus 1x. So when y equals to 0, okay, plus 2a plus 2z equals to 0, which means now a plus 1x equals to, move this to the right side and take out the minus. And at the same time, take out the 2 as well. Okay, so it will be a plus 1z. So the a plus 1 can be cancelled off, which means now your x is basically minus 2z. Okay, so I will get my eigenvector, then now you see the x already found. X depends on z. Alright, so means that I let my z be, let's say just now I used the t and s, then now I use u. That means my x is going to be minus 2u. Okay, so which means my x, y, z is going to be, my x is minus 2u, my y is 0, my z is u. Therefore, I factorize a u, I get negative 2, 0, 1. Okay, then now I will get my eigenvector. So my eigenvector is going to be E3, that is minus 2, 0, 1, when the lambda 3 is minus 1. So once I have found all this, I can substitute into my equation. Okay, look at here. This is a degree 4 equals to PD P inverse. So a degree 4 equals to PD P inverse. So basically the D will be the degree 4 of the eigenvalues. Alright, so my D will be, first eigenvalue is A, so A degree 4. Second eigenvalue is 1 minus A, now becomes degree 4. Okay, then the third eigenvalue will be minus 1 because of the A degree 4 there. So I will get A degree 4, 0, 0, 0, 1 minus A to the power 4, 0, 0, 0. Power 4 of minus 1 is 1. Okay, and the corresponding matrix P will be the eigenvector for the first eigenvalue. So which is our E1. So my E1 is 1, 0, 0. That is my first column of the matrix P. Then when my lambda is 1 minus A, which is my lambda 2, it will be 2, 1, 1. Here is 2, 1, 1. Then lastly, it will be negative 2, 0, 1. Okay, so that's the matrix P. Alright, so let's move on to one more part here, D. So which means now, use the characteristic equation of A to find A power 4 in terms of matrix A and the small letter A. Alright, so now we need to refer back to our characteristic equation. Characteristic equation is this. This is a characteristic equation. So A minus lambda I, then 1 minus A minus lambda minus 1 minus lambda. So 1 minus A minus lambda, then minus 1 minus lambda equals to 0. Okay, so here I will do expansion. Now I will expand first two brackets first. So when you do expansion, you will get A minus A squared minus A lambda. Then the minus lambda times to the bracket, it will be minus lambda plus A lambda plus lambda squared. So all of this multiplied with minus 1 minus lambda equals to 0. Okay, so now before I expand, I do expansion again, I simplify the terms. Then I will rewrite here, it will be A minus A squared minus lambda plus lambda squared. Now multiply with minus 1 minus lambda equals to 0. So now, firstly, all this bracket, all the terms inside the first bracket times by minus 1. So just change the sign. Okay, then next, you multiply with minus lambda, all these terms. So I will get minus A lambda plus A squared lambda plus lambda squared minus lambda cubed equals to 0. Alright, so now I will simplify the terms. Let's see any terms that can be cancelled off. So this minus lambda squared and lambda squared cancel off. Alright, so that's all. I think that's all. Okay, so now I will rearrange it. So it will be negative lambda cube, then followed by lambda. So here lambda, lambda, lambda. I will factorize the lambda. So I factorize the plus lambda, it will be 1. Okay, here is 1 minus A plus A squared. Okay, then the remaining terms will be minus A plus A cubed. Sorry, A squared. Second term is A squared. That equals to 0. Okay, and now look at the question. We need to find A degree 4. So now I will get lambda cube as a subject. So I times whole equation by minus 1. Means that lambda cube, then minus lambda, I rearrange a squared minus a plus 1. Okay, I times minus, it will be plus a minus lambda squared, plus a minus a squared equals to 0. Okay, then now I will change it to matrix A. Now, a minus a squared is actually a constant, but then when you convert it to matrix, you have to times by identity matrix. That's why you see the I at the back. Okay, and now we need to get a degree 4. So now, to get a degree 4, I will times a. So here, a degree 4 minus a squared minus a plus 1 plus, so a times I is a. So this is the constant. Alright, then now in order to get a degree 4, just move the last two terms, these two terms, to the right side. Then you'll be getting the answer. So therefore, a degree 4 is a squared minus a plus 1, this is a constant, times a squared plus a minus a squared times capital A. Okay, so that is the solution for this question. Right? So we have come to the end of the question and also comes to the end of the video. Alright, so thanks for watching. Please subscribe to my channel if you enjoy watching my video. Thank you. Bye.